Hi, I'm Kirsch. I'm a senior electrical and electronics design engineer, formerly at Intel, and also a former adjunct professor in electrical and electronics engineering. In this video, I'm going to cover two of the most important concepts in the flyback converter. That's one, the transformer, and two, the snubber circuit, so it operates nicely. I'm going to demonstrate this in Allegro X software. So open up your software if you have it and follow along, and I'll show you the critical things you need to look for in this flyback converter circuit. All right, so here I have the flyback converter circuit. This is designed to take an input range of 9 volts to up to 25 volts. And the nominal voltage it's operating at is about 12 volts. Now, I bumped it up to 16 volts for the purpose of this video, and I've input a realistic power supply. Now, the output for this circuit is set to 5 volts and 2 amps. That's what it can support, a 5 volt, 2 amp load. Typical for your power brick that you'd use to plug your USB Type-C device or something like an iPhone. The switching frequency I chose for this circuit is set to 250 kilohertz, and the maximum duty cycle I allow is 40% duty cycle. So those are the specs for this flyback. Next, let's look at the transformer specs. The first thing I think about with a flyback converter is getting the transformer specifications correct. So in the next section, I'm going to go into the transformer specs and how you would set those in Allegro. Here we've got our transformer, and if I were to zoom in here, we'll take a closer look. There's a lot going on here. First of all, the core transformer. You'd get this from your PSpice options. So you can go to Place, PSpice Part, and choose your modeling application. In the modeling applications, it's in the system modules, and it gives you the options for setting your transformer, and I chose the flyback. Okay, so here, if I were to Shift N, let's look at the specs that I set. We have the primary winding inductance, or LP. That is set for whatever calculations you do. So I set mine to 15.6 microhenry based on my calculator. And then we have the primary winding resistance set to 30 milliohms. The secondary winding resistance, 12 milliohms. The turn ratio, N2 over N1, 0.83. And then leakage inductance. Okay, so you're going to use your own calculator to get these numbers and then set them inside this modeling application. You place that onto the schematic, and there are a few more things here. We have this capacitance between, or parasitic capacitance between the primary side top and bottom rails, and then there's a capacitance between the bottom, the non-dotted side on the primary, and the non-dotted side on the secondary of my transformer. So you're going to need these little capacitances on here because these are realistic and practical in any flyback transformer or coupled inductors. Lastly, there's one more capacitor that I put on here, capacitor on the secondary, a little bit of parasitic capacitance there, 60 picofarad. Now the output voltage for this circuit depends heavily on the transformer, but the general equation is V out is going to be equal to your input voltage times your duty cycle, so 40%, the number of turns on your secondary side of your transformer, the number of turns on your divided by the number of turns on your primary side, and all that divided by 1 minus your duty cycle. So you're going to need to know that duty cycle that you'll allow, that maximum duty, primary and secondary side windings of the transformer, and Vin. And that's all you need pretty much to make your circuit, to make your flyback converter V out. Once you have your transformer model with the values in there, you drop it in the circuit, it should be fine, right? Not necessarily. There's one problem with the transformer, or these coupled inductors, and that is leakage inductance. And it's a bigger problem than you might think. See, the transformer, it gets energy stored into the primary inductor, and then once that switch is turned off, it gets dumped into the secondary inductor. Those two inductors, they're not coupled perfectly, and that leakage inductance is what spills over and causes voltage spikes and unwanted currents on the primary side of that flyback transformer. In the next video, we'll see how this leakage inductance causes problems and how to fix that with a snubber circuit.